This example is a really good one because you're now putting together all of the things you've learnt so far about resolution of vectors. So we're going to resolve a vector here, which they've given, into rectangular components, one of which is parallel to this other vector. First thing I'm going to do is to define the vectors. I'm going to call the first vector A, and I'm going to call the second vector, and I should really say let here, let A equal I plus 3j minus k, and let B equal 2i minus 2j minus k. So we've got that straight away. So what we're now going to do is just have a look at that as a diagram as well. And I'm just moving this so it's a little bit more better set out. Okay, so we're going to draw a diagram now, and the diagram is going to show what we're looking for. So we've got A, here's A. I noticed that we're looking at something which is parallel to this vector, which is my B. That's my A. So this is a kind of in the direction part here. So if we're looking at in the direction, remember that that vector would go along the bottom. So we're really interested in two parts here. The vector U, okay, which is the parallel to B part of the vector. And then we're also interested in a W because this is our perpendicular part, perpendicular to B. So effectively what you're looking for is A equals, and we'll call this one W, U plus W. And our job is to try and find this parallel part, U, and the perpendicular part, V. Now the thing to remember is that U is going to be the vector resolute of A in the direction of B. So that would be A dot B. Remember that the in the direction part is always the one that goes here and underneath. So you've got U. W equals, if we're going from this end of W to this end, we could go backwards along U, so negative U, and then we could go forwards along A. So we've basically got A minus U. So once we've got U, we've got W, essentially. Okay, so our goal is to try and re-express the vector A in that form. All right, so we can do that. Let's start. So first thing we're going to do is find A dot B. And we've got A and B here, so the coefficients of I multiplied together, the coefficients plus the coefficients of J multiplied together, so that's 3 and negative 2, plus the coefficients of K multiplied together. And they're both negative 1, so that's kind of nice. 2 minus 6 plus 1, which is going to be 3 minus 6, so minus 3. So we've got A dot B. We also need B dot B as well. So again, coefficients of I multiplied together, that's going to be 2 and 2. Coefficients of J multiplied together, negative 2 in itself, and the coefficients of K, negative 1. So we've got 4 plus 4, because this turns into a positive, plus 1. 4 plus 4 is 8, plus 1 is 9. So what that also tells us is that the magnitude of B is 3, because this is the magnitude of B squared. Okay, cool. So we've got B dot B, we've got A dot B, so we now have U, which is A dot B, over B dot B, which is here, 9, times B, which is 2I minus 2J minus K. That's U. And also, if you wanted to simplify that, and again, I'm just copying it so I don't have to rewrite everything. Oops, would have been easier to rewrite it. Is you can simplify this fraction. So 3 over 9 would be the same as negative a third. Okay, so we've got U. So that's one of the things that we needed. Knowing what U is, we are now able, to find W. So on the next page, I'm just going to copy that. We know that W, and again, just going to this page here, there's our format for W. So we can use that. So since W equals A minus U, this means that W equals A, and A is here, I plus 3J minus K. I plus 3J minus K minus U. And you can see here that this is a negative. So I'll just put it all here so you can see. We're also going to expand this out because this is not really in a form that's very useful. So I plus 3j minus k plus 2/3 I plus, in this case here, and I've actually just made, you can hear planes going overhead. I've got here two negatives, that's 2/3 plus this negative here, so it's a negative 2/3 j. And again here I've got a positive 1/3 k, but then this negative here, so negative 1/3 of k. So we've now got, we can put this all together, I plus 2/3 of I, that would be 3/3 here, so we've got 5/3 of I, so they're done, just put a tick there. 3 minus 2/3 j, and this is 3 is 9/3 minus 2/3, so that would be plus 7/3j, so they're done. And then minus k, so it's minus 3/3 minus 1/3, so minus 4/3 of k. And just to make it neater, I'm going to take the third out the front, so we've got 5i plus 7j minus k inside the brackets. Now to finish this off, you can see here that what we've got so far, we've now got w, which is awesome because that's the other thing that we wanted. Let's do a nice box around that. So we've got two things, u, which is here, and then w. Now the thing that we're asking, and look at the question again to see what we needed to find the resolution of this vector A into its rectangular components, one of which is parallel to B. So that was this idea of finding A, which is u plus w. So now all we need to do is use this to find this vector into its two rectangular forms. So I'll put this one up the top, and now we put everything in. So we've got our vector, which is going to be our resolve vector of A equals u, and we know that u is up here, so we had negative 1/3 of 2i minus 2j minus k plus 1/3, and it's all this stuff here, which is w, 5i plus 7j minus k. Now incidentally with that, what you could do is to express that out again, expand everything out, and what you should find is that in doing that you end up with A, because that's what A is. So for example here, we've got, if I expand this out, we'd have negative 2/3 plus 5/3, well that's 3/3, and that's I. So you'll get A back again. So you can do two things here. You can check whether or not you've got A back here again, okay? But what you've done is divided this up into two parts, the parallel part and the perpendicular part. And it's usually a good idea too to actually say what these things are. So negative 1/3, 2i minus 2j minus k is the parallel component. And the other part, the w, is the perpendicular component. And I'm just putting in brackets here to B, so we know it's perpendicular to B. Okay. Now it's a great idea as well, just as a final check, that is the end of the question, so you've actually found A in its parallel and perpendicular parts. Actually have a look at this vector here, the 5i plus 7j minus k hat. Doesn't really matter about the third, that just changes the size of the vector. But let's check whether this vector here is actually perpendicular to B. Okay, so I'm going to use the CAS for that. So first of all, I'm going to put B in, 2 minus 2 minus 1. So using the CAS, get a vector. So 2 minus 2, and then 1, yep, or minus 1. I'm going to store that as B. And then for my other vector, oops, that one, we'll put in what we found. So that was 5, 7 and negative 4. 5i, well, oops, plus 7j minus 4k. And I'll store that, I'm just going to call that C, doesn't matter. Okay, so let's do the dot product. So remember that you can find dot product just by going into the book here and going to D, dot product. One more, there it is, dot P. we just have to put B and C in there. And you can see their dot product is 0. So these two vectors are indeed perpendicular. So that means going back to the work that we've done, we've now shown that W is indeed a perpendicular vector to B, so it's the perpendicular component to B, and that U is a parallel component to B. So our two vector components, U and W. And the key thing here is, notice what B is, 2 minus 2 minus K. U is 2 minus 2 minus K with a scalar multiple at the front. We found that K was that scalar negative a third. So we know definitely that U is also parallel to B.